Okay, so the lesson is on finding the real zeros of a polynomial function. So when a polynomial function is not giving you the zeros, it's not in factor form, you have some ways to find the zeros. But sometimes it's not super obvious. So of course, we search for the obvious routes first. We start factoring what they all have in common. And then once we get it down to a quadratic, we can use our methods of quadratic formula or factoring or completing a square to go ahead and clean those up. Now, sometimes it's not so straightforward, so we have other methods. So let's back up first and start by looking at how to divide polynomials, because it's going to be very important to use this method later on, all right? So let's show you how to do long division with this. So here we have a problem. We have an x to the fourth minus 3x cubed plus 6x squared minus 9 divided by x plus 2. There's two ways to do this. The first method is called long division, which is just like when you were doing, 694 divided by 32 back in grade school. So we're going to do the same thing here. We're going to write long division the way you would. One thing you got to keep in mind is you need some placeholder for the missing x terms. So if you have x to the fourth minus 3x cubed plus 6x squared. Notice I don't have an x term, right? So you want 0x minus 9 and divide this whole thing by x plus 2. Okay, now, just like what we did in grade school, you want to try to get it as close to the term as possible. Now, what is different this time is actually a lot easier to figure out what you want. You want to match the first term with the first term. In order for x to become x to the fourth, you need to multiply by x cubed. So you need an x cubed, right? And then you use that to multiply the dividend outside. So you use that to multiply by, sorry about that. You use that to multiply this one outside, right? So make sure you multiply x cubed with that. So you would get x to the fourth plus 2x cubed. Now remember, in long division, we're subtracting this term, right? So we're subtracting the whole thing. All right, so if you go through this, and if you did this successfully, the first term should cancel out beautifully, okay? And now you subtract that, you go negative 3x cubed minus 2x cubed, so minus 5x cubed. And just like long division, you drop the next term, plus 6x squared. Okay, we keep going. We want the first terms to match again. So just like before, we want this first term here to match the x, right? In order for it to match, we need negative 5x squared. Distribute that through, you get negative 5x cubed minus 10x squared. And again, don't forget you're subtracting the whole value of this. Okay, if you did it successfully, first term should cancel out beautifully. All right, now you have 6x squared plus 10x squared because minus a negative. So 16x squared. Again, drop the next term. Sorry, I'm a little bit crooked here. Plus 0x. Okay. All right. So just like before, we wanted to match a 16x squared. In order for x to match 16x squared, we need 16x. So then distribute, you get 16x squared plus 32x. Okay. Subtract both terms. First one cancels out. All right, let's keep going. You get 0 minus 32x, so negative 32x. Oops, sorry about that. Okay, so negative 32x, and then drop the last term, negative 9. So in order for this to match up, you want to multiply by negative 32. So negative 32x minus 64. Subtract the whole thing. Okay, so you have negative 9 minus a negative 64. So that's really negative 9 plus 64. So I get negative 55 as my remainder. So your final answer will look like this. You will have your quotient up here. That's your answer. So x cubed minus 5x squared plus 16x minus 32. And then you write your remainder, that negative 55, as minus 55 over the divisor here of x plus 2, right? That is the answer to this division problem, okay? So this is the method of long division. You may want to see this a few times to get used to it. Synthetic division is a little bit quicker, but synthetic division is only useful if you're dividing by a linear function. In fact, most frequently, it has to be a single x plus or minus a number. Okay, so first thing you want to do for a synthetic division is take that divisor there, so x plus 2 equals 0, and solve for it, so x equals negative 2. Then you put that negative 2 in what we call a jury box. I call it a jury box, just in a box on the corner. Okay, all right, now we take our, I'm getting these numbers, I'm getting these terms a little bit confused, but basically your numerator, take your numerator, and now you're going to just write the coefficient of the numerators, but don't forget the placeholder. So it's going to look a lot like what we did here. All right, so you're going to write the coefficients is going to have 1 for the x to the fourth, -3 for x to the cubed, 6 for x squared, 0 for x, -9 for the last term. Okay, give it a little bit of space because you'll need to write something there first. Okay, the rule of synthetic division is you drop the first term. This first term, nothing happens. Just drop it down here. Then you need to take this new 1, multiply by the jury here. So 1 times -2, you put it here. And then you add those two up. So you get -5. Repeat that process, multiply by the -2, so you get 10. And that'll give me 16. Repeat the process again, -32. Drop that down, add that up, -32. And lastly, multiply that together, you get 64, and I get 55. You should notice that these numbers are looking very familiar because they should match the same thing here. And this is your remainder over here. Oh, I found my mistake. This is a positive 55. All right, that's great. So now this is a plus. Okay. Beautiful. Okay. All right. So now how do I do the synthetic division? How do I rewrite it? So your answers here will start 1x power less. Your numerator here had x to the fourth. So this will pair up with x cubed, x squared, x, and then x to 0. So when I write my answer, it's going to look like x cubed minus 5x squared plus 16x minus 32. And then that 55 is a remainder. So plus 55 over, all right, my denominator is x plus 2, x plus 2. So that is synthetic division versus long division, okay? All right, factor theorem is a theorem that tells us that when you plug in your c, when you plug in your factor into your function and you get a 0, that is a factor, right? So vice versa, if it is a factor, then you plug in the c, you will get 0. So it says use factor theorem and synthetic division to determine if a x minus 1 or b x plus 3 is a factor of the function. Okay, so we're going to do a and b, right? So a is x minus 1. All right, so let's practice synthetic again. We want to solve for this, x minus 1 equals 0, so x equals 1. Put the 1 in your jury box, all right? And now the coefficient of my numerator, this is what I'm dividing by, my f of x. Notice I'm not missing any x terms, so x cubed, x squared, x, beautiful. So just write the coefficients, 2, -1, 2, -3, okay. All right, synthetic division says drop the first term, so 2 comes down. Multiply that 2 by the 1 in the jury box, so that's 2 again. Add it up, you get 1. Multiply, you get 1. Add, you get 3. Multiply, you get 3. Ooh, I get 0. So that tells me then that is a factor. That number is not only the remainder, but it's also the value of when you plug in the factor into the function. So really, when you plug in 1, your answer is 0. So that tells me f of 1 equals 0. So yes, x minus 1 is a factor. In our previous answer, you notice how my last number was 55. So because it's not 0, it's not going to divide nicely. Therefore, it's not a factor. We had a remainder, right? So let's see if the other one is also a factor. So you have x plus 3. Okay, so I'm going to solve for that. X plus 3 equals 0. X equals -3. Okay, so -3 is what's going in the box. And then my coefficients here are 2, -1, 2, -3. Okay, so now I'm going to drop the first term, 2. Multiply 2, -3, so -6. Add that up, -7. Multiply -3 with -3, -3 with -7, so 21. Add that up to be 23. And then 23 times -3 is -69, so I get -72. Oh, it doesn't equal 0. So f of -3 is equal to -72, right? Sometimes this is a lot easier to do than plugging the number in, right? So rather than plugging it in and doing all the powers, this is maybe a little bit quicker. So no, x plus 3 is not a factor. Okay. All right, moving on. All right, so this is what we're talking about. So when you have a polynomial function, there's a lot of possibilities in terms of what your factors can be, especially when it's a higher power, right? We talked about how there's no formula for x cubed, x to the fourth, or x to whatever power. The only formula we have is x squared. So we call this p's over q's, all right? So p and q. So you want to find the factors of the constant. So factors of the last term here. This is the p version, okay, the p values. So what are the factors of -6? Well, it could be plus or minus 1, right? And plus or minus 6. And then the other one will be plus or minus 2, and then plus or minus 3, right? Because 1 times 6 will give me 6. But then there's a combination of the positive negatives because you get the -6. Same thing with the 2 and 3. You want some combinations there, okay? And then the leading coefficient, the leading number here, that's your Q, okay? So then the only ways to get 2 is plus or minus 1 and plus or minus 2, okay? So what are the possibilities? This is called P over Q. So the formula is P over Q. You basically list all the combinations of P divided by Q. So the first one will be dividing by 1. So that one's pretty straightforward. 1 divided by 1 is still 1. So 1. 2 divided by 1 is 2. 3 divided by 1 is 3. 6 divided by 1 is 6. Okay. Now you want to figure out the other combination, like pairing up with the 2, right? So let's keep going. 1 divided by 2, so plus or minus 1/2. 2 divided by 2 is 1, so we already have the 1 in the list. Don't need that. Next one is 3 divided by 2. And then the last one will be 6 divided by 2, which is 3. We already have that. So instead of, endless possibilities, we now have 1, 2, 3, 4, 5, 6. 6 times 2. We have 12 possibilities. It's not a small list, but it's definitely smaller than just randomly guessing. All right, so these are the possible zeros for you. Okay, and now what do we need to do? We then need to use synthetic division or long division to try and see which one of these are truly our factors. Which one of these, when we plug it in, we'll get zeros and they become our factor. So that's what we're doing to check and find the zeros of a polynomial function. All right, so let's see. This was the same exact one, so we don't need to do it again. So let's see. Yes, this is 2x cubed plus 11x squared minus 7x minus 6. Okay, so here's our list of possibilities. I'm going to list it again down here so I don't have to look back again. Or actually, I'm going to copy this list over so I don't have to look at it again. Okay, so here's a list of my P over Q. Okay, my possible list, right? P over Q. So now I'm going to go ahead and test. You have to test and see which ones are truly your factor. This is why synthetic division is a little bit faster, because then you can test it quickly rather than using long division. And the good news is this is x cubed. So once you find one of your factors, you are going to shrink it down to an x squared, a quadratic, and then you can use your quadratic formula or factoring to get the rest of the answers. So typically, I would say you start by dealing with the first couple of tries, so like 1 and 2s, right? So I would try 1s and 2s first, and then if I need to, I go with a bigger number. So I try 1. Okay, my numerator is this: 2, 11, -7, -6. Okay, drop down the 2, multiply, I get 2, so that's 13. Multiply, that's 13, that gives me 6, 6, 0. Oh, I got really lucky. The first number I try is already 0. Beautiful. So now that means this becomes 2x squared plus 13x plus 6. Okay. All right. So now I need to figure out how do I factor this to make it even, to find out the rest of the zeros, right? So 2x squared plus 13x plus 6. I know that 2x squared can only be possible with 2x times x. To get that 13, I need a 6 and a 1. All right, I think that gives me a 13x. So this term right here, this 0 right here, don't forget, it's not 1, it's actually x minus 1. So now my function here is really f of x equals 2x plus 1, x plus 6, x minus 1. So then you want to find the zeros. So the zeros are, solving these, you get -1/2, -6, and a +1 when you set each of these equal to 0 like we did a couple lessons ago. Okay, so these are the zeros of the function. All right, so we're going to continue on. Same thing, we're going to make our list, right? So remember, P's over Q's. So P's are down here. So the possible list of P's are 1, 2, 3, 3 times 6, 2 times 9, 1 times 18, right? Q is 1 and 3. So my complete list of P over Q is going to be all these over 1. So 1 divided by 1, 2 divided by 1, 3 divided by 1, 6 divided by 1, 9 divided by 1, 18 divided by 1, and then 1 divided by 3, 2 divided by 3, 3 divided by 3 is 1, 6 divided by 3 is 2, 9 divided by 3 is 3, 18 divided by 3 is 6. So my list is complete. So I have 2, 4, 6, 8, 10, 12, 14, 16, 16 possibilities. Okay, well, now I got to try, right? So I'm going to test the first one. 1, my terms are 3, 5, 25, 45, negative 18. Always double check. Am I missing any powers? 4, 3, 2, 1. Not missing any powers. Okay, drop the first term, 3. Multiply, you get 3, 8. We add 8, 33, 33, 78, 78. You can stop here because you know this is not going to be 0, right? So this one's not going to work. All right, try the next one, negative 1. It doesn't matter which one you start. Just make sure you do test out all the possibilities. You could start with negative 1. It's totally fine. Whichever one you want to start testing, right? Okay, so let's see. I have 3. Now I go 3 times negative 1 is negative 3. Add that up is 2. 2 times negative 1 is negative 2, so 23. Multiply, get negative 23, and I get positive 18. Negative 18. Oh, this is negative 36. Nope, that doesn't work either. Okay, well, let's keep going. Looks like the negatives will be working better for me looking at the terms. So maybe I'm going to be smart and try negative 2 instead of just 2. Okay, 3, 5, 25, 45, negative 18. Drop the 3, multiply, I get negative 6. That's negative 1. Multiply, I get a positive 2, 27. All right, multiply, I get negative 54. I add that up, I get negative 9. Negative 9 times 2 is 18. Oh, finally, I got a 0, right? So now my new function from here is going to be 3x cubed minus x plus 20, minus x squared plus 27x minus 9. All right, so you can make a new list and check and see if they are the zeros. But you can also look at what I have here and maybe see if this is factorable, right? And I think we lucked out. If we factor by grouping, this one versus this one, it's going to factor out to be x squared times 3 minus x, right? And then you have your 9. You have 3. Oh, sorry. Oh, this is why. Yep. Okay, try again. Factor out x squared, you get 3x minus 1. Okay, I want a minus 1, so plus 3. That gives me, not 3, sorry, one more time, plus 9. 3x minus 1. Okay, all right. So I get 3x minus 1. Remember, we did this a while ago, so that's your factor. And then you have x squared plus 9. Okay, so this is my 0, and these two parentheses will give me my zeros as well. So you solve for it, go 3x minus 1 equals 0, 3x equals 1, x equals 1/3, and then don't forget x squared plus 9 equals 0, x squared equals negative 9. Take the square root, x equals plus or minus 3i. So your extensive list of zeros, remember it's x to the 4th power, so you have 4 zeros, right? You have negative 2, 1/3, plus or minus 3i. These are all your zeros, okay? All right, last one here. Let's try this. Again, we have our P's and Q's. Our P's are these factors. So, oh, that's nice and easy. It's 1 and 5, right? So P's. Q is the same thing, 1s and 5. So your P over Q, the list is actually not too long. 1, 5, and then P over Q, you have your 1 divided by 5, so 1/5, and 5 divided by 5 is 1. So you actually only have 6 of these to check. Okay, so let's start with the first one. 1, you have 5, 19, negative 25, and oh, I covered my own writing there. That's a positive 5. Okay, so positive 5. All right, drop the first term, multiply, you get 5. That's 24. You multiply, you add, you get negative 5. Negative 5, 0. Wow, we lucked out again. So this one now gives me 5x squared plus 24x minus 5. Okay, this one factors really nicely. You get 5x, because that's the only way to get x squared, right? And then you want 24, so I'm thinking I need a positive 5 to get a positive 25, and minus 1 here to get negative 1 to get 24, and multiply to get that negative 5 on the back. Okay, so you need to solve 5x minus 1 equals 0, x equals 1/5, and then x plus 5 equals 0, x equals negative 5. So my zeros are negative 5, 1/5, and don't forget you have a 1 here. That's your other 0, okay? All right, let's see. Make sure you take some time to finish out the last two to wrap up the zeros, and I will post the completed notes on Canvas for you so you can follow along, okay? All right, that's it for today.